that we can actually use these two call it properties or PVT properties that we just learned about, this BGD and little rs, and we can calculate what we call a equivalent formation volume factor for gas reservoirs, essentially. The only thing you have to do is to take that BGD value and divide it by the little rs. The nice thing about that is that you get the exact same units as the formation volume factor for oil, the so-called BOI, which is reservoir barrels per stock tank barrels. But this you can do even for a gas reservoir, or if you have a gas cap and an oil rim in a reservoir, you can do this in a consistent way such that you get a total formation volume factor for that reservoir volume. Also very, very user-friendly in, for instance, unconventionals that span a wide range of fluids. So this is what we call the geologist BOI, and we use quotes for it because it's kind of like some people have also called it a pseudo formation volume factor, but it's essentially just this I guess ratio right here to the right. What you'll see is that when we talk about a producing GOR, and the producing GOR is also changing through time, unless you're above the saturation pressure that we just talked about. If you're in the undersaturated region, the producing GOR will not change. And it also comes, these definitions with all these subscripts becomes very handy when we also look at this equation, because it accounts for both the phases or both the gas volumes that we measure at surface that originates from the oil and the gas phase respectively. And the same goes for the surface oil volume, that we account for both of the surface oil volume originating from reservoir gas and the surface oil volume originating from reservoir oil. The reason why producing GOR changes through time is because all these different parameters also change through time, unless we are in the undersaturated region, of course.